Permutations and combinations. First concept is factorial. Symbol exclamation mark or the symbol inside the number like factorial 5. So we write factorial 5 or this type factorial 5. Now meaning of factorial. Suppose we have factorial 5. So it can be written as 5 into 4 into 3 into 2 into 1. Suppose we have factorial 7, it means 7 into 6 into 5 into 4 into 3 into 2 into 1. Suppose there is factorial n, then we can write it n, n minus 1, n minus 2, dot dot dot, then 1, 2, 3, etc. Now, next thing is permutation. So permutation is written as NPR, where n is greater than or equal to r. Now, NPR is equal to factorial n divided by factorial n minus r. Example, suppose we have 3p2. It means factorial 3 divided by factorial 3 minus 2. That is factorial 3 divided by factorial 1, which will be equal to 3 to 1. Now, there are some more concepts like factorial 0. Factorial 0 is 1. Factorial of negative numbers, minus r, where r is a number. So it will be infinity. Like factorial minus 5 is infinity. Now let's see some questions. Suppose question is, if NP4 equals 20 times NP3, then what is n? Let's see. So NP4 can be written as factorial n divided by factorial n minus 4 equals 20 times factorial n divided by factorial n minus 3. Now, we have to check which factorial, like either n minus 3 factorial or n minus 4 factorial is greater. So here, clearly, factorial n minus 3 is greater. This can be checked by putting some values of n. Suppose we take n equal to 5. So from here, we get factorial 1. And here we get factorial 2. So definitely factorial n minus 3 is larger. So now what we do, factorial n minus 3 can be written as n minus 3 times factorial n minus 4. So now factorial n upon factorial n minus 4 equals 20 times factorial n upon factorial n minus 4 and times n minus 3 outside the factorial. So here factorial n minus 4, factorial n, factorial n, factorial n minus 4 will cancel out, and we will get n minus 3 equals 20 or n equal to 23. Now we can take another example. Suppose we are given 2npn and it is to proved as 2 power n, then 1, 3, 5, dot, 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 2n minus 1. Let's see how. So we consider LHS 2npn. It can be written as factorial 2n divided by factorial 2n minus n, that is factorial 2n divided by factorial n. Now we expand factorial 2n. So 2n, 2n minus 1, 2n minus 2, 2n minus 3 till 2, 1, whole divided by factorial n. Now we keep outside even numbers. So 2n, 2n minus 2, 2n minus 4, dot 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 4, 2 in one bracket. And we write other thing, remaining things like 2n minus 1 times 2n minus 3 times till 5, 3, 1, whole divided by factorial n. Now from here we can take common 2. So in each term 2 is present, and since these terms are total n, so we can say that 2 power n is common, then we will be left with n into n minus 1 into n minus 2 till 3, 2, 1 times second bracket 2n minus 1, 2n minus 3, etc. till 5, 3, 1, whole divided by factorial n. And we know that factorial n can be written as n, n minus 1, n minus 2, dot 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 till 3, 2, 1. So here this term will cancel out, and we will be left with 2 power n times 2n minus 1, then 2n minus 3 till 5, 3, 1, which is our answer. Now let's see some rule. If there are n objects, the rule is there. If there are n objects in which P are of one type, Q are of second type, and rest are different, in that case, total number of permutations will be equal to possible permutations will be equal to factorial n divided by factorial p factorial q. Let's see one example. In how many ways the letter of Allahabad be arranged? So here, if we count, A is occurring 4 times, so 4 A's, and L is occurring twice, 2 L's. So number of ways equal to total number of letters 1, 2, 3, 4, 5, 6, 7, 8, 9. So factorial 9 divided by factorial 4 and factorial 2, which can be simplified, and after simplification we will get 7, 5, 6, 0. Now next rule. So if there are r places are there, and which are to be filled by n different ways. R places are there and different ways are there. In that case, possible permutations would be n power r. Let's see by one example. In how many ways? Question is, in how many ways 3 prizes be distributed among 5 students? There is no restriction. So answer will be as per rule. n power r. So here it will be, if there are 5 students, 5 power 3 will be the answer, number of ways. Now let's see next rule. The rule says number of circular permutations will be equal to n minus, n minus 1 factorial if there are n objects, provided they are distinguishable. If they are non-distinguishable, in that case this value will become half. Let's understand it by an example. So example 1, in how many ways can 8 friends sit around a round table? 8 friends are there and they sit around the round table. So how many ways are possible? So number of circular permutations are factorial n minus 1. So possibility will be 8 minus 1 factorial, because the distribution will be distinguishable. Now let's see another example where distribution is non-distinguishable. Suppose in how many ways, question is there, in how many ways 8 flowers be arranged in a garland. Obviously, distribution will be non-distinguishable. So number of ways will be factorial n minus 1 divided by 2. So number of ways equal to factorial 8 minus 1 divided by 2. That is factorial 7 divided by 2, which is 5040 ways. Now let's see another example. In how many ways can, next example is there are 3 men and 3 women, 3 men and 3 women. So question is, in how many ways can 3 men and 3 women be seated at a round table if no 2 women sit together? So let's see, 3 men, since there is distinguishability, so 3 men can sit in factorial 3 minus 1, that is 2 ways. Now 3 women can sit in 3 different places in factorial 3 ways. So total number of ways will be 2 into factorial 3, that is 2 into 3 into 2, that is 12 ways. Here in first case, while making the seating arrangement for men, the rule of circular permutation is applied, but in second case, we write it in simple way. Now, let's see concept of combination. So, combination is written as NCR, which is equal to factorial n divided by factorial n minus r times factorial r. here NC0, this will give 1. NCN will also give 1. NC1 will give N. And if we relate NCR with NPR, so since NPR equal to factorial N upon factorial N minus R, and NCR equal to factorial N divided by factorial N minus R factorial R, so clearly we can say that NPR multiplied by 1 upon factorial R. Here, either we can write this here in place of this, we can write NPR. So NPR times 1 upon R equal to NCR. Now, let's proceed. Let's see one theorem. NCR plus NCR minus 1 equals N plus 1 CR. Let's see how to prove it. So factorial N upon factorial N minus R factorial R plus factorial N upon factorial N minus R plus 1 times factorial R minus 1. And we are considering LHS first. So now let's continue. So here we know that factorial N can be written as N times factorial N minus 1. Similarly, if we apply that rule here, so N minus R plus 1 can be taken common. That is factorial N minus R plus 1 will be equal to N minus R plus 1 times factorial N minus R. So, and it will become factorial N divided by factorial N minus R factorial R plus factorial N from here factorial, sorry, N minus R plus 1 times factorial N minus R times factorial R minus 1. Now, if we take common factorial N upon factorial N minus R, and here one thing can be done, we can multiply by R and R. So this term R times factorial R minus 1 will become factorial R. So we can take common factorial R also. So factorial R, then here 1 plus R divided by N minus R, N minus R plus 1 will be left. Now we take LCM. So what do we get? We get factorial N upon factorial N minus R factorial R times N minus R plus 1 plus R divided by N minus R plus 1. Now R will cancel out. So in the numerator, we will get N plus 1 times factorial N divided by, in denominator, it will become N minus R plus 1 times factorial N minus R times factorial R. So this will become factorial N, and in denominator, it will become factorial N minus R plus 1 times factorial R. And if we expand RHS, the same result we will get. Let's see. So RHS will be n plus 1 CR. So it will become factorial n plus 1. Here this becomes factorial n plus 1 because n plus 1 times factorial n. And so factorial n plus 1 divided by factorial n plus 1 minus r times factorial r. So if we compare this equation 1 and equation 2, both are same. Hence, our result is proved. Now, let's see one more question. So, question is NCR plus NCR minus 1 equal to N plus 1 CR. So, consider LHS. LHS says NCR. NCR can be written as factorial n divided by factorial n minus r factorial r plus factorial n divided by factorial n minus r plus 1 times factorial r minus 1. So further we write it factorial n divided by factorial n minus r, and this factorial r can be written as r times factorial r minus 1 and plus factorial n divided by, here this can be written as from this rule factorial n equal to n into factorial n minus 1. So this rule we are applying here, n times factorial n minus 1. So this will become n minus r plus 1 common or outside, and then factorial n minus r times factorial r minus 1. Now factorial n, n minus r, n minus r, r minus 1, r minus 1 factorial can be taken common. So factorial n divided by factorial n minus r and factorial r minus 1 when we take common, then we are left with 1 upon r plus 1 upon n minus r plus 1. So if we take LCM, factorial n divided by factorial n minus r factorial r minus 1. So here n minus r plus 1 plus r divided by r times n minus r plus 1. So r will cancel out and we will be left with n plus 1. So n plus 1 times factorial n will become factorial n plus 1. So in numerator, we will get factorial n plus 1. And here in denominator, n minus r plus 1 times factorial n minus r will give factorial n minus r plus 1. So in denominator, we will get factorial n minus r plus 1 times, what is next? Here r times factorial r minus 1 will give factorial r. So this will be factorial r. Now consider RHS. So in RHS we have, suppose this is equation number 1. Now in RHS we have n plus 1 CR. So we can write it factorial n plus 1 divided by factorial n plus 1 minus r times factorial r. And this RHS. So LHS is factorial n plus 1 divided by factorial n minus r plus 1 times factorial r. RHS is also the same, factorial n plus 1 divided by n plus 1 minus r factorial r. Hence the result. Thank you.